Guys, so this is the review packet that I gave you earlier this week, and we went over it as a class, and you were told to study it every night for our upcoming CBA. So gonna make a video going over it again, so you can hear it as you study this weekend, because I know you all will. All right, physical properties of matter. This would be 5.5a. Okay, that's the first TEK that we learned this year. With physical properties of matter, that is the different characteristics that you can use to describe a piece of matter. Okay, so stapler. Okay, I'll put the stapler here. Okay, we'll say that's our piece of matter that we're observing. All right, I can measure its mass by putting it on a balance. Okay, and then that's actually weighed in grams. Okay, I can put a magnet up to this and see if it's magnetic. If it is, that's great. If not, that's great too. That's the properties of matter, right? Physical state just means, is this a solid, liquid, or gas? Well, I think we can all see that it's a solid. Relative density, this is whether matter sinks or floats in water. So if I put this in a bucket of water, is it going to sink or float? Solubility in water, whether matter dissolves in water. Again, if I stick that in water and stir it around, is it going to dissolve? Probably not. Thermal conductivity, whether matter conducts or insulates heat. Now, interesting, this part is metal, this part is rubber. So if I put fire to it or put it on a hot plate and was cooking it, this part back here too is also rubber. Would this part get hot? Would this part get hot? All right, so make sure you know metal will definitely get hot if heated. Rubber will not, because this is a conductor of heat, and rubber is a insulator of heat. Remember, insulator holds it in. Conductor lets it flow. All right, and the same thing with electrical conductivity, whether matter conducts or insulates electricity. Once again, rubber and metal, and we know from Ms. Baxter that metal to metal is always a conductor of electricity, but rubber is an insulator. So if I hooked up a circuit to here, would it flow through? What if I connected the circuit here? Would it flow through? All right, so that's just basically physical properties of matter. Okay, you can do that with anything. I really challenge you to grab something on your own and go through here and make a list, okay, describing it. Do something at home. All right, relative density. Again, that's that word, and that just means is it sink or float. If it's less dense, it goes to the top, and more dense sinks. So let's talk, we can put wood chips, right? And down here could be a paper clip. All right, because we know a paper clip will sink and wood chips will float. What else will float? A ping pong ball. Ping pong ball. Okay, and again, less dense floats, more dense sinks. What about if we had oil and water? Which one would be on top? Oil, and then water down here, right? So let's draw a line. Make a little cup, I guess. All right. Now let's talk about measurement tools. Triple beam balance and double pan balance. All those just measure the same thing, mass. A graduated cylinder measures volume. And what is the only state of matter that you can put in a graduated cylinder? Is it solid, liquid, or gas? Liquids. And then a scale is weight. And I'm pretty sure if any of you have ever been to the doctor, you know what that is. Okay. Constant properties of water. Now, this is that 3.5C TEK. Okay. This is that TEK that you learned in 3rd grade, that we talk about all the time. Boiling point of water is 100 degrees. It's always 100 degrees. And if you can't, and remember what I told you, you have to know 2 numbers in 5th grade science when it comes to Celsius, and talking about temperature. And it's just 0 and 100. Okay. 100 is easy. It only goes to one of the three things. Here's 1, here's 2, here's 3. It only goes to 1, which is the boiling point. And I can remember that because boiling is super hot. Therefore, 100 degrees is super hot, right? Okay. Next, 0 degrees Celsius is related to freezing and melting point. Okay, so I think where some of the confusion is coming in is that on my anchor chart, it says the point refers to the temperature that change happens. So ice cube coming out of the freezer, we're still stuck on that. It comes out of the freezer and it hits the ground. When it's in the freezer, it's 0 degrees Celsius. It has to be that to be frozen, okay? The freezer has to be 0 degrees Celsius or colder, okay, to keep the ice frozen. Once it falls out of the fridge and it hits the ground, is there a change about to happen? Yes, there is. It's going to start melting, right? So what is the temperature it's at? What is the temperature it needs to be at to start that change? 0 degrees Celsius, okay? So at 0 degrees Celsius, that change is about to happen because it's starting to melt. So I hope that helps clarify that up a little bit. All right. So let's talk about some more changes in matter. This is also 3.5C. Process: condensation, evaporation, freezing, and melting. Let's start with evaporation again. And we're going to talk about the story with the shower, right? We'll start there. I'm turning on my hot water so I can take a shower. That liquid is coming out of the faucet, right? And it's starting to heat up because no one wants to get in a cold shower. You want to let the water run so it heats up. You get in, and or as you go to open the door, pull the curtain back, you see all the steam. That's that liquid coming out of the faucet turning into gas, okay? And that's caused by heating. Heating does that. When you heat up water, it turns into a gas, okay? Then we'll put a shower heating up. Maybe that'll help you remember that. Next, that's why I like to start there. We'll go here, condensation. So what is condensation? Well, that's when that gas, that steam from your shower, it starts filling up the whole bathroom, and then it hits that cold mirror. And that cold mirror takes that steam and turns it into little tiny water droplets. So gas goes back to a liquid. And that's happened because remember we said the mirror is so cold, so it's cooling. Okay? So we can put steam hits shower. All right? Next, freezing. So remember I said I was going to be like the really nerdy scientist, and I was going to go and get my cup and try to suck some of that water up off of the mirror. Well, great. I sucked it up off the mirror. I got a cup full of a little bit of water. And I want to stick that water into my freezer. So I took that liquid and I'm going to turn it back into a solid by cooling it. Because when you put it in the freezer, it's going to cool down. It's going to get cold. Okay. So we can put here cup in freezer. And then, let me number these. This is the order I'm going in. And then last, okay, that was fun. Now I want to do one more thing. I want to take the cup back out of the freezer, that solid of ice, and I'm going to want it to go back to a liquid. Okay? And I can make that happen by letting it heat up or just leaving it out of the freezer because I don't need it to be 0 degrees Celsius anymore. It can start melting, which is also 0 degrees Celsius. So we'll say, how about we say we put the cup on the counter? Because once it's on the counter, it's going to start melting, correct? Counter. All right. And that's changes in matter. Next, mixtures and solutions. Mixture is a combination of two or more substances. Okay. The substances maintain their physical properties when they're together. Example are iron fillings in sand or the big old bucket of candy. Okay? This is a mixture. When I mix this up, is any of these pieces of candy changing their physical properties? No. Is this solid all of a sudden now a liquid? Does this solid now all of a sudden lose its mass? No. When I mix this up, do these nerds now become magnetic even though they weren't before? No. So this is a mixture, okay? Now let's talk about solution. A solution is also a combination of two or more substances. The physical properties of substances change though. Now, so that's salt and water, right? If I take salt and I shake water and I stir it up, can I salt anymore? No, it completely dissolves, okay? So that would be a solution. Kool-Aid, tea, anything that you mix and it dissolves, one thing has to dissolve inside of it to be a solution. Okay, it has to completely lose its physical property. So like that salt, it's a solid, but when it goes and mixes up, can't see it no more. It changed. It's gone. Salt and water, and we can put tea and sugar, right? I'll ask you, can a solution be a mixture? Yes, everything starts mixing. Think about it. You have to mix for it to be a solution. Mixture be solutions. But can a solution... Wait, I said that all wrong. Solutions are mixtures, are not solutions. My bad. All right, I'm going to keep going because I'm running out of time. All right, this is not on our CBA this time. Uses of energy. Melts. Remember? Here, let's just do these together. I told you to remember the uses of energy by remembering the word mechanical, electrical, light, thermal, sound. Mechanical is anything that moves. Anything that moves. Your hand, my pen moving, my pen, riding a bike, and it moves is all mechanical. As turbines are just the blades on like fans or windmills. Okay. Electrical, what powers your computers and lamps? Have come from electrical. Light, that's solar panels. Well, light is light. I mean, solar panels, you can put light bulbs, right? Anything that produces light. The sun. All right, thermal, that's heat. Heat. And sound, hearing messages, but I want you to put the word vibration next to it. Might help you. And last, oh, by the way, this is 5.6a. All right. Force friction is just a force that works against motion. So, bicycle incident we were talking about, riding a bicycle on the grass is harder than riding it on the concrete because the grass provides friction. Let's put bicycle too. Gravity, that's the force that pulls objects to one another. So gravity is pulling you down, pulling objects down to the earth. Force, that just means a push or pull. Force, I'm creating force. And motion is just movement. All right, this one we don't need to do. And circuits, last one. Circuits talks about open circuit, closed circuit. And then you've got series and parallel. Series has path. Parallel has two more. Okay. If a series circuit, the whole, if a parallel circuit breaks, some of it still works. Okay. So towards in her room, and the lights go out. She has like several strands of lights where some of them have gone, but the work because she bought the good ones, the parallel circuit kind. She bought the cheap ones, and the series one, none of the lights would work. Your study guide. Bye.